Okay, my other article I want to talk about is a new survey called the High 4 Pi. It's an all sky survey looking at every direction in space of what is called neutral hydrogen. Neutral hydrogen, the most simple element, is a proton with an electron going around it. The element of hydrogen is the most common in our universe, and much of it is in the neutral form. Well, it actually emits in the radio part of the spectrum via a mechanism where the electron going around the proton, when the spins are aligned, which is what this is showing here, can then flip to their misaligned. This is a lower energy state. And so when it goes from this state to this state, it emits a little bit of energy, a photon, and that little photon is radio emission with a wavelength of 21 centimeters, or 1420 megahertz. This is how we detect the neutral hydrogen. And this survey is the highest resolution survey that has been done to date. Here's a map here, and I'll show that in a little bit more detail here. It was taken by the two largest steerable radio telescopes that we have. They're shown at the same scale, but this one is 100 meters. It's in Germany. And this one is about 65 meters. It's in Australia, covering the two hemispheres, so you can make a total map of the entire sky. And so obviously there's some overlap, and there was a lot of data processing to basically meld those two images, represented millions and millions of observations. Here again, here's that map a little bit closer, and I'm going to show you a couple of different maps that they do in the radio. So this is showing you essentially a brightness map in this 21 centimeter wavelength range here. So you're seeing where all the neutral hydrogen is, where it's brighter. In the yellow here is where you have more column density of the neutral hydrogen. And to compare it with the previous survey, which was done about 8 to 10 years ago, I believe. Here is it on the left here. This is the Draco cloud, so you can see how much better resolution this same area is. You're starting to see structures and filaments within this. This is actually a section near the Magellanic Clouds, which are the nearby galaxies. Here is again, these are the Magellanic Clouds, the small and the large Magellanic Cloud, seen from the southern hemisphere site. And then these are actually M31 and M32, I believe, the Andromeda galaxies. Here, see how much better resolution this is giving you on the sky. Now, I actually like this representation of this map better, and I'll show you a couple other maps. But when you take radio data, and you're not only getting image at in that part of the spectrum, you're getting at a specific wavelengths, which indicate how that gas is moving toward you or away from you. So this is that same data that's been scaled in terms of whether that gas is coming toward you or away from you, and you can see the scale bar over here. So this area over here, and I should mention this is looking out at the entire sky, looking toward the center of the Milky Way galaxy. This is the plane of the Milky Way galaxy. Our orientation in our solar system has nothing to do with that plane, and you can see where the hydrogen is in there. So that part's coming toward us. This is coming away from us. You can see the Andromeda galaxy is actually coming toward us. The Magellanic Clouds are actually moving away from us here. So it's looking at every channel and seeing where does that 21 centimeter line actually peak in the spectrum, and it tells you how fast that gas is moving relative to you. So I've got a couple kind of cool videos here to show. This one here, it's got a little bit of music going to it, but this is just very relaxing and stuff. So it's showing you that same map, asleep out there. But this is looking at the northern galactic pole here, and this is looking at the southern galactic pole, so you'll see the Magellanic Clouds actually coming here. So that is where those actually taken. This is where we try to do a lot of observations of galaxies, because this is good for doing extragalactic work, because you want to be able to see where there's no hydrogen in your way when you're looking at galaxies that are external to our Milky Way. Most of this gas that we're seeing are in our galaxies. Obviously, it's not everywhere. This next image video I'm going to show you will actually scale through the velocities there. So it'll go from velocities that are coming toward you to velocities that are going away from you. And this is my favorite because you really see all the structures of, and it's where they peak. And you can see the velocity values in kilometers a second here. So these are ones that are coming toward you, and then we're going to see this end of the galaxy pick up first. So you're looking at the intensity in individual velocity channels. And it gives you appreciation of how much data there is in this data set. And this will ultimately be used by other astronomers as a new, survey data sets are great to have when you're doing other studies on these objects. And you can see now we're going to go here, and these are the ones going to be moving away. We're still moving toward us, and they'll start to pick the ones that are moving away from us over here. You can see the bubble that's coming out of the, see that those lobes there? I forgot to point that out. So if you know, kind of the rotation of the galaxy and things like that, this is one of the first measures that we did to figure out how our own galaxy was rotating. But there's peculiar velocities at any given location, but it helps you kind of reconstruct the three-dimensionality of what's going on in our galaxy. Just show this image one more time here without all the grid lines and stuff. But see this vortex up in here and these other flows of some sort that are coming through here. There's just tremendous structure in here. It's like looking at this thing now in high res as opposed to low res television now. That's the kind of step that they have made in this new survey.